In this video, we're going to create a pulse using step functions that we talked about earlier in a previous video. So we're going to create a pulse using unit step functions. So here we have a pulse that has a value of 3 between 1 and 3. And these are the two step functions that I'm going to show you how we generate it. In this pulse, we see that we're going to turn on at 1. So we need something, a function, a unit step function, that went from 0 to 3. So we need to have an amplitude of 3, so we take this step function and we multiply it by 3. So that gives us the amplitude. But then we need to turn on the step function at 1. And that's where our argument comes in, where our argument that turns this on is t minus 1. Again, the way to think about this is set the argument equal to 0. And that implies that at time t equal to 1, that's when we have this step function here turning on at 1. Again, this has a height of 3. Now we go back down 3 at time t equal 3. So here we have a negative 3, which implies that we go down, and then we turn that on going down at time t equal 3. So that's our function. Again, we use the argument t minus 3 is equal to 0, and then this function turns on at t equal to 3 going down minus 3. Now this total function is equal to the sum of these two step functions. So that's how we generate a pulse using these unit step functions with a particular amplitude. Here's another example, except we're going to write a mathematical expression using unit step functions when we're given a particular graphical waveform. So here's this example. We're going to write a function, mathematical expression in terms of unit step functions. So v of t is going to consist of a whole bunch of step functions. So here we start at 0 and we go down minus 2. And we go down minus 2 at negative 1. So first our amplitude, we go down negative 2, and then we turn on at negative 1. So this is the argument then is t plus 1, because when we set the argument to equal to 0, t is equal to negative 1, and that's when this function turns on. Now at time equal to 1 here, we go up all the way to 3. So that implies we went from minus 2 to 3, so we have to go up 5 steps, 5 units. So here we have a plus 5, and then we turn on at time t equal to 1. So our argument needs to be t minus 1. Okay, then we start at 3, and then we go down all the way to negative 3. So we went down 6 units. So, and then we went down 6 units at time t equal to 3. So we went down 6 units at time t equal to 3. And then at time t equal 4, we went up 3 units. And then that leads us back to 0 again. So here we went up 3 at time t equal to 4. So this mathematical expression here describes this arbitrary function. Now I have another slide that shows you the breakup of these step functions to add up to this function that we just did earlier. So here this went down at minus 2 at time t equal to negative 1. This went up 5 at time t equal to 1. And this went down, this step function went down minus 6 at, turns on at t equal to 3. And then finally this last step function here goes up 3 at t equal to 4. And when you add up all these step functions, you get this waveform that was given. So hopefully these two examples illustrate how you can represent functions mathematically, like these type of functions right here, in terms of unit step functions.